Alright, hi everyone and welcome back to the channel. So today you're joining me here outside the observatory, and as you can see it's another crystal clear blue sky. Since I've been home, the last 11 nights have been clear skies just like that above me, and it's been like that all through the day as well, so it's starting to look like summer here in Cyprus. So hopefully the weather will continue with the clear skies at night and allow me to get on with some more imaging sessions like the ones I've been doing over the last few nights. So here we are today outside the observatory, as I said, and today I'm going to start off my next project on the observatory, and this one is all about power. So here at the moment, this is how I get my power into the observatory. It's just a long 50-metre extension lead that runs all the way back up the garden through the bushes and finds its way into the house to get some power. However, I really don't like having that cable strewn through the bushes and just waiting for one day to get some vermin or whatever eat it and end up triggering a fire in the grasses or in the bushes. So I really want to get rid of this cable. And the second reason for it is obviously to try and give me some backup capability in the power. Here in Cyprus we do get power glitches now and again, particularly if there's a storm rolling around the island somewhere. We do get power fluctuations, and we have actually had one evening where the neighbourhood was hit by lightning and it blew cables off the power lines, and the power in the house was all doing some weird things, and I ended up having battery chargers and phone chargers, Sonos speakers, an Xbox and a few other pieces of electronic equipment were destroyed during that electrical storm. So having some isolation from the system as well would also give me that bit of clean power, and also give me the backup capability if the power does go down for any reason. It doesn't interrupt any imaging sessions. So today is really just going to be an introduction into the project, what I've currently come up with in terms of the design, and we'll take a look at some of the hardware, what I'm planning on putting together, and where I'm going to install everything around the observatory. So, time to get rid of this cable. Alright, so the first thing we're going to do is take a quick look under the observatory. Okay, so here we are under the observatory. Now this area here is directly below the rear bay of the observatory, where all the power cable comes in and where all my adapters and extensions and all that sorts of stuff sit for all the equipment in the observatory. So what I'm planning on doing in this area is actually to put the battery bank for the system. So what I'm going to do is build a 24 volt system, so I'm going to use two 12 volt batteries, and the ones I've purchased are 200 amp hours each, so that should give me plenty capacity. Depending on how much capacity I've actually got, once I do some testing and things like that, it might be able to allow me to add some small fans in the summer, or cooling in the summer, and some heating in the winter, just try to regulate the conditions inside the observatory. So I'll have the two battery banks here, and the cables will go basically straight up into the bay of the observatory, and allow me to do all the equipment install in the power bay that I've previously mentioned in some of the videos in the observatory there. So this is where the batteries are going to go. So here's the two batteries that I've procured, and here are the solar panels that I'm going to use to supply the system power. These are 380 watt panels each, your standard size. I think they're roughly 2 meters by 1 meter in size, and I've had a couple of options for where I'm going to put the panels. I'll just show you the locations in a minute, but I think that might just be a temporary location, because what I was thinking of doing is, once I build the second pier for the outside rig, I might make some sort of sliding roof to put the panels on, which will also then act as a cover. But we'll see how things get on. At least at the moment I've got locations nominated for where I can put the panels. So this is one area that I'm thinking of putting the panels, next to my black pipe spiral. So this is actually the black pipe spiral that I use for heating the swimming pool. So back in the corner under the fruit trees over there, I've got another solar panel and a car battery which I use to drive a small 12-volt bilge pump, and that just circulates water out of the pool through the black pipe all day, and then it dumps the water obviously back in the pool. And you can see that on my other channel, my personal channel, of that system there, and that automatically starts and stops itself in the morning based on temperature, and runs all through the day quite happily, and then shuts itself down at night once the sun departs and the system equalises again. So that's been really effective over the last couple of years. And when I did a calc based on the volume flow and the temperature rise, it's probably equivalent to a 5 kilowatt heater running all the time inside into the swimming pool. So the temperature of the swimming pool is just sitting around at the moment around about 32-33 degrees or something like that. So this is one location here that I'm thinking about putting the panels. It might mean I need to move the black pipe slightly, and also just to avoid the shade as this palm tree above me swings round as the sun, but at the moment it should run quite happily there all day. So that's the first option. So the second option I'm looking at is this area here. The observatory just sits behind this oleander bush there, so it would give me a straight run with the cable straight in. And the benefit of this area here, it's dead ground, it doesn't get used for anything, and it means it's also not going to get impacted by any shadows or anything from the bushes or the palm trees around the other area. And it's an easier cable run straight into the power management area. So this is the second option, and it's next to the driveway, so there's no hassle. Nobody's going to be throwing stuff at it or breaking it or anything, and that's what I'm currently thinking is the best option. So I'll just mount the panels here and run a cable into the back of the observatory, which is probably about 7 meters, something like that, to the observatory. Alright, let's head into the observatory. Alright, so here we are inside the observatory, and I've just turned the fan off. It's I put it on there just to cool me down a little bit, but it's far too noisy to record with. Temperature inside the observatory is sitting 37 degrees at the moment, so a little bit toasty. Anyway, so here's the power cable that comes in through the door of the observatory, just up into this, the extension rail, and then it just splits out into the various distribution blocks for all the equipment. You know, I've got the two main blocks there. I've got the one sitting on the rig pier behind me, and I've got also a couple under the desks for all the laptops and the Wi-Fi router and all that sorts of stuff. So there's power all over the place. So what I plan on doing is I'll reconfigure this entire area and put all the solar equipment inside here, and as I said, directly below this bay is where I'm planning to mount the batteries, so they're out of the sunlight, but there's also enough breeze circulating through there just to keep them cool and to stop any build-up of any gases and things, any off-gas off the batteries, should there be any. So what I'm planning on doing is I'll probably put in additional layers to this wooden backboard. I haven't had a look exactly yet how I'm going to configure all the equipment, but what I'm thinking is I'll have the solar equipment on the back rails, then I'll have the power distribution rails, and then the power control rails or something like that, or some configuration, and that'll allow me to then get access into the various systems depending on you know what sort of access I need into things. I've also got to consider the cooling. So I've got the fan in this bay here, not this big fan, but there is a fan mounted on the bay of the observatory. I want to get a hold of another one of them for the other side, and just to get some an increased air circulation through the bay. And as I say, it's running at 37 degrees in here today at the moment, and I might have to put some additional fans just to circulate air through to keep all the equipment warm depending on how hot it gets. So that's the area where I'm thinking of doing it. And then for the power distribution, I haven't yet decided if I'll run single feeds from the panel or take out a primary feed and then distribute it at the pier behind me, or once I build the second pier outside, put some sort of box or something out there, but that's all down the road after I get the main system built. Alright, so let's head inside now to the house and we'll have a quick look at the design I've come up with and take a look at some of the hardware and what my thinking is for some of the design and the power distribution. Alright, so let's head inside. On the screen in front of me here you can see the provisional system design that I came up with. So I spent a bit of time looking at various manufacturers and various components and what all the different aspects of the systems were. And I settled on Victron Energy, which I could easily get hold of, buy it off of Amazon or in some of the local suppliers here in Cyprus. However, buying off of Amazon and shipping it direct from Germany was a lot cheaper than paying the local prices here on the island. And obviously being part of the EU, you don't have to worry about any custom or import duties and things like that. So I elected to go for an easy source of supply, and everything was available from the various suppliers through Amazon or fulfilled directly by Amazon. And so I just slowly built up the system of what I was trying to achieve. So when we look at the system here, I've designed it in a way that I can have multiple phases in terms of get the basic functionality up and working first, and then extending the system with additional load capacity or additional battery charging for the shutter system if I wanted to change out the existing charger. And also the fourth phase, you can see bottom right, allows me to add remote monitoring over the internet and trending and things like that through the Victron remote monitoring service. So the first phase of the system was primarily to get the solar panels installed, get the battery systems operational, and provide both 240 volt AC circuits and also 12 volt DC circuits. So we'll follow through the design, and I've got the components that I've purchased so far, and we'll take a quick look at them. So everything that's in the white area of the sheet, so the top of the sheet, that's the phase one, that's everything that I've purchased so far. And then the future phase two and future phase three and future phase four on the bottom right and the grey boxes, they're all add-ons that I can put on at a later date to further extend the system. One other thing that I'm looking to do down the line is obviously give remote control of all the devices inside the observatory, so whether it's the cameras, the mount supply, the laptop supplies, all these sorts of things, be able to turn things on and off remotely to give me a bit of flexibility should a device lock up or I want to do a complete start-stop remotely of the observatory. And to do that, I was going to look at doing some sort of Arduino based or Raspberry Pi based system. And that is something that I'm still looking at. If we flick over to this relay control sheet, so if we come off the 12 volt DC circuits and come on to relay control, this is the sort of thing I was looking at. And basically we'll have the Raspberry Pi connected up to the Wi-Fi router, either over Wi-Fi or over Ethernet, and have some sort of shift register board to control all the digital outs, because obviously you've got a limited number of I/O on the actual Raspberry Pi itself, so we need some sort of buffer board to allow us to control more outputs. And then the relay boards, they already got these that I'd purchased for some playing around. So here we can see one of the relay boards here. Now all these relays are rated up to 10 amps, both in DC and 240 volts or 250 volts it says on them, and up to 30 volts DC, all at 10 amps. So that's more than ample for each of the circuits that I could potentially looking to control. And then I would build some sort of website or application on the device there that I can then talk to it over the internet through a web page and control the devices independently, and potentially even extend the system to include home integration either through Google Home or likes of Apple Home or whatever it's called, Alexa, to do remote controlling. So I was also poking around on the internet and looking at extended I/O boards and things that I could use for this purpose, and I did find these IO 032 boards over in the UK. Now these they'll give you an additional 32 IO per board, and you can have up to 4 of these boards connected to Raspberry Pi. So ultimately, that's plenty, 128 I/O channels that I can use for controlling the relays on these individual boards. And one thing I thought about doing as well is have a mix of digital in and digital out, and I could use the digital in on systems to pick up the opposite contact on each of the relays, so I could monitor for the actual relay switching and give me feedback real time in terms of what's actually switched over, just to provide some additional feedback into the system. Now there's lots of other options out there. There's, needless to say, there's really expensive options that can do all sort of load monitoring and all that sorts of things on individual channel basis. And there is devices out on the internet or components out on the internet that I could potentially, if I get more advanced and adventurous, look to build my own custom circuits. I have found Texas Instruments do a nice little load switch MOSFET that also does load monitoring. So that's potentially another option as well I could go down. But these IO 032 boards, for the sake of 15 UK pounds for 32 channels, allowing up to 4, as I say, per Raspberry Pi, that gives you a lot of flexibility in what I could potentially do. But that's for a later phase in the project. Alright, so if we come back to the design, so we've obviously got the solar panels coming in from on the centre top, and they'll come in through the charge controller. This Smart Solar charge controller, same as all the Victron Energy products in this Smart range, they all talk to each other via Bluetooth, via the Victron Connect app, which you can install on your phone or your tablet. And you can also get an additional adapter to plug it into a USB port on a PC and give you full access to configure and control all the various components on the system, as well as monitoring all the loads, etc., on the batteries, the battery condition, the voltages, etc. So let's take a look through each of the components that I've bought so far. Obviously we saw the solar panels lying outside, so I've got 2 380 watt JSSolar solar panels. They've got a peak open circuit voltage of, I think it's around about 35 volts, whatever your typical is for a solar panel, and your normal sort of 12 amps per panel. So the Smart Solar charge controller I went for is the MPPT 130, which allows up to 100 volts on the PV side and 30 amps both on the panel side and on the charge side to the battery. So effectively a 30 amp charger. So with 2 380 watt panels, that'll give me around about sort of nominally 80 volts at 12 amps, something like that, 10-12 amps on a good day. So well within the limits of the charge controller. So this is the charge controller here. So if I switch across to this view, we have a look inside what we get. So inside the box, this is what the charge controller looks like. As you can see, I have not been into any of this stuff yet. There we get usual instruction manual. So here's the MPPT charge controller. Smart Solar brand is range, as I said, which is all Bluetooth connected. And we've got the terminals here for the battery and the terminals for the solar panel. And there also is a VE Direct, which is the Victron Energy communications bus, so that you can do wired connection back to the likes of the the servo GX if I could want to, although they will all talk over Bluetooth. So quite a hefty chunk, nice piece of kit, feels rugged and solid, and certainly the reviews online are looking positive for the whole Victor Energy line. So that's the MPPT 130 power controller. So the next thing on the circuit, as we can see here on the top, underneath the MPPT charge controller, is the Smart Battery Protect. So these provide you battery protection and it monitors for over voltage, under voltage, over current, or whatever it is it can do. And it'll disconnect the batteries if you did see the need to, depending on the settings you've configured in the device. Now with these Smart Battery Protects, they're unidirectional, so you can only flow current through them in one direction. And that's why you can see on the drawing here, the power comes in through the in terminal and goes out through the out terminal towards the battery. So let's go look for that. I've got it in a box here somewhere. So this one here is the 65 amp. This is the smallest in the range. Yeah, here we go. So this box, yeah, the Smart Battery Protect. You've got your main power cable, power connections coming in and going out, and there's an LED status just for which protection algorithm you're running on the system. And then we've also got some digital contacts here that you can set off an alarm or for accessing the programming mode remotely. And we've got this, it's called a remote connector, and it allows you to put a relay contact on here should you desire for terminating or turning on and off the supply or the charge out to the battery. So this is the 65 amp one. As I'm building a 24 volt system, so two 12 volt batteries running in series. This is the 12, 24, 65 model, which is perfect for coming in off the solar PV panels and going to charge the batteries. So after that, it also comes with this power cable for battery monitoring or battery power, ground to control the device, and that just plugs into the remote terminal on here, and then you just hook it up to the negative of the battery to function with the device, I believe. Alright, so we've come out of the first Smart Battery Connect, and you can see the second one down below. As I say, these are unidirectional, so you need one for on the circuit coming to the batteries, and one on the circuit coming off the batteries to all your loads. So we'll come into the batteries. On the batteries themselves, if I can find them. So here I've got two of these battery sensors, smart battery sensors. Again, both communicate with the parent devices via Bluetooth. And what we've got here is you attach these to the battery and connect it to the terminals, and that will give you temperature and voltage monitoring of the battery, and allows the MPPT charge controller to optimize the charging cycle on the battery and make sure that you're not doing damage to the batteries. So these are rated for both 12 volt, 24 and 48 volt systems, and you just simply stick this onto the side of the battery. It comes with an adhesive back panel, and then you connect this to the positive and negative of the battery, and in here we do have a fuse just to protect the device should there be something. So I've got two of them, one for each of the batteries, and this is the second one, exactly the same. So just below the batteries, you can see we have a battery balancer. So you connect this onto the batteries and you wire it so that you have got monitoring capability of both the batteries, which will be connected in serial. So here's the battery balancer. As I say, you've got connections here for the batteries, so you put onto the positive of the first battery, so the top battery in the circuit, and then you put it onto the negative of the bottom battery in the circuit, and then you've also got this common, which is the midpoint between the two batteries, and it will monitor the voltage on the two batteries, and it will move power back and forth between the batteries just to make sure they're balanced. And I think it can transfer up to 5 amps of power back and forth between the batteries there to keep them balanced. And we've also got a couple of volt-free contacts for reset and an alarm, so that if the device malfunctions for any reason, you can hit a reset, or you can drive an alarm with a signal off of it. What you can do is you could take a signal off the alarm contacts and put them into lights of the Servo DX module and allow you to tell there's an issue with the battery balancer. Now the only problem with the battery balancer is these don't have Bluetooth integration. They're just straight dumb units effectively, and there's not a lot for you to, there is no possibility to connect and see what they're doing over Bluetooth. So whether they'll come up with a revised product in the future, we'll have to wait and see. So that is the battery balancer, and that sits, as I say, connected to the batteries, top battery positive, bottom battery negative, and then the common midpoint between the batteries. So we come off the battery and we're in through the second battery protect. This box. So as this one's taking a lot higher load on the system, it's rated much higher. So this is 225 amp model. Or no, this is the smart shunt, sorry. So this is a smart shunt that's at the bottom. You can see the black unit here. This is rated for 500 amps, and you basically put this as the last device on the negative supply, or the negative cable, and it monitors all system loads through the battery, and allows you to do the proper monitoring of what's coming and going from the battery. So this is the smart shunt rated at 500 amps. Again, it does have a VE direct, should you want to connect it back directly over cable to the likes of the Servo DX unit. And it does also have a couple of terminals for connecting onto the batteries for monitoring the voltage in the system. Again, so yeah, quite a hefty shunt. It is a smart one, so it is Bluetooth, and it will connect back to the rest of the system to do remote monitoring as well. So that's the smart shunt that sits on the negative of the system, the ground of the system. So let's go to the other battery protect. This is it here. Yeah. So the second battery protect is this larger blue box in the middle. Again, it's unidirectional, so this is only be connected up in one direction. So it's significantly larger than the first battery protect, which is only on the charging circuit. So again, we've got an in and an out on the system. We've got the remote contact plug for doing a remote on and off should you need to, and then it has the same connector for going onto the ground plane of the battery for powering the unit. Now this one's rated at 220 amps, and is more than enough for what I'm looking at powering on the system. Alright, so that is the Smart Battery Protect for the load side of the system. So the next thing we have in the system, isolated DC-DC charger. So this is actually going to be used for the 12 volt circuits on the system. And the one I went for is isolated 24 volt and 30 amps. Again, quite hefty lump of equipment. So here we have it, the Orion-TR Smart. Again, it's all Bluetooth to connect back to the system. And this will handle an input of 16 to 35 volts, and the output is adjustable between 10 and 15 volts, and it will give you a 30 amp capacity through the system on the DC loads. Down at the bottom, there must be in the box somewhere, yep. So it comes again with one of these little remote plugs that allow you to do remote on and off, connect it back to a relay somewhere, or you can just leave it on all the time and you can control it remotely over the system. So it's just a straightforward, we've got the DC volts coming in off the Smart Protect on the load side off the batteries, and then your output's going out to the devices on your net. And these, I believe, as I say, they are adjustable 10 to 15 volts, so that you can tweak up the voltage slightly and give you better stability on any of your high current devices. And I believe that if you tweak it up slightly as well, it will help the likes of the mounts with the torque loadings and things on the motors. But we'll wait and see how that goes on. So it's a 30 amp DC to DC charger. Although it says charger on it, yes, it can be used as a battery charger, but you can change the mode of it to act as a power supply. The main item is the Victron Energy Phoenix Inverter. So this is a 24 volt DC input, and it will give out 240 volts up to 1200 VA. So I think that works out at a peak load capacity of, I think, 2200 watts with a nominal full load running watts. I believe it is the Phoenix Inverter. It must weigh around about 5 kilos or something like that. 24 volt input, 230 volt 50 hertz output at 1200 VA. As I said, left hand side, at this side of the unit here, you can see we've got our DC power coming in. We've got another remote charge port, remote control relay port, and then we've also got the VE direct bus connector for going back to the Servo GX should we desire it in the future. And then you've got an off one switch there, an equal mode switch. On the other side, it's just a straightforward, as I'm over in Europe, it's got a Shuko, whatever type of connector it is, your round European plug, and standard one of them with a flying lead I will take out to the UK 3-pin plugs that we use here in Cyprus, and I'll just put some normal wall mount sockets and take a flying lead from a Shoko plug for that. Now this Phoenix inverter does not have Bluetooth, and so what you need to do is, here we go here. So to allow you to communicate with this and get all the data coming off of it, you need to use a VE direct to Bluetooth adapter, effectively a Bluetooth dongle, and this is it here. And what we do is we connect that into the VE direct port on the inverter, and then that'll give you Bluetooth connectivity to the rest of the system for monitoring and controlling what's going on the system. So at least we've got remote capability as well with the unit. So that is the AC inverter, DC to AC. So, looking at the design, we've obviously got a whole bunch of interconnectors and fuse rails and everything. So for the fusing, I have gone for these MIDI fuses. They take fuses like these. This is a 150 amp one that I've got for the main supply of the battery chargers. So that's your fuse will just be mounted in there, and then you just bring in your crimp connectors onto those fuse terminals. So if we look at the design, I've been checking the specs of the various components in the system, and the maximum rated fuse coming off the PV side is 40 amps, and going into the inverter is rated at 100 amps as a recommended maximum fuse on there. It isn't internally protected as well with a 100 amp fuse, however recommend an external fuse. So I've got a whole bunch of fuses, different ratings, 40 amp, 100 amp, and a few kicking around. It's more than 50 to pop something. Yeah, 30 amps for going off to the DC to DC chargers. So the 100 amp, if you look at the red fuse distribution rail, we've got 100 amp, 30 amp, 30 amp, and 30 amp going out to all the various parts of the system. And then the 40 amp coming in off the MPPT through the smart battery protect to the battery, and then the main 100 amp, 150 amp fuse coming off the battery into the system. So all the necessary fuses for that. So what else did we get? So the distribution blocks sit in the middle of the drawing. So I got a red and a black one. These are quite chunky fuse heavy duty charged distribution block. Open. There we go. So the big distribution bar, I think these are all M10 bolts for distributing the power out to the system. So there we can see they sit in the center of the system. There is the main distribution for the panel. So we've got exactly the same, another one for the negative side of the system. Next up, I've got my hands on a couple of battery isolators. So these are obviously allowing me to turn off the system if I want to be doing working on it, and just to disconnect the batteries from the system. So it's just your standard high current battery isolators. I can't remember what these are rated at, something like 250 amps or something. But yeah, just a straightforward heavy duty battery disconnect. Allow you to do maintenance in the system. So I've got a couple of them. I haven't quite decided yet how we're going to integrate them into the system. As you can see on the drawing, I've got one coming off the top battery going into the system, and another one between the batteries. But I'm not quite sure yet if that's how I'm actually going to do it. Certainly the recommendations in the design is a fuse between the battery and the isolator, for your fuses back at the closest point of protection to the battery. And then I don't know whether or not yet I'll install one between the batteries, but I like the idea of being able to have both the batteries disconnected from each other on the positive side there, just for the sake of being able to isolate things properly while I'm messing around near the batteries, because there's a lot of energy stored in them. So when I looked at the designs of the various components and looked at the maximum cable capacity that they can handle, so these are all the battery cables. So coming off the distribution board going into the inverter, it takes a maximum 25 square millimeter cable. So I've got a load of that. So connect up, and then for the smaller loads, the 30 amp loads, I have these 16 square mil cables, and then I've still got to look at the main power cables coming in off the batteries up to the distribution blocks. Although 25 mil squared is probably adequate, to probably maybe beef that up to 50 square mil or something like that. But I'll wait and see. And also, same as the cable between the two batteries, we'll probably look at properly doing a plus connect or something like that in between, depending if I put an isolator in there or not. So that's all the cable just to get it going, and then all the downstream side of things after the DC to DC inverter, DC to DC chargers, and the Phoenix inverter, and then it's all into just your standard cabling out to the lower load devices, depending on what I end up doing. So that is the basics of the design of the system that I've come up with, and this is really just the first part in the series here, just to give an introduction into the design of the system, what I've come up with, which components I've got, and in the next part of the video we'll look to actually start installing some of this gear inside the observatory, getting the panels, solar panels mounted in the garden, and doing whatever we need to do to get the progress on the system. And then once we get the phase 1 done and dusted and get the system basically working, then maybe down the road we can look at adding in the phase 2, phase 3 and phase 4. But the priority at the moment is obviously just to get the basic system working. As I've got a 240 volt AC inverter going in there, once I've got that up and working, then I can easily transfer all the existing observatory across onto the inverter, and that'll let me get going without having to worry about any direct 20 volt DC loads for the time being. Alright, so that's the first part. Thank you very much for watching. As I say, in the next part we'll get into the build, and please feel free to ask any questions and everything down below, or if you get any feedback, guidance or anything like that you might find, or I might find useful or interesting, please don't be afraid to drop a comment below. And thanks for watching, and look forward to the next one. Don't forget to like and subscribe, and most of all, please drop any comments and feedback below. So thanks for watching, Chris guys, see you in the next one.